Yo, what's up? It's Astro Seagull Codes here, back with another video, and today we're going to be going over the bag ADT abstract data type. The bag is very similar to the set, if you are familiar with that, and basically you can remove and add to it. However, you can only get at a random indice. So the reason why I put a graph and model in this thumbnail is because the bag is often used in statistics and modeling and standard deviation and just, yeah, and analysis models. So we're going to be going over the bag real quick. So we have two instance variables, type T of an array of bag, and a capacity that the user has a choice to input through one of two constructors. And you see that we have a super here, and we extend array collection. So this came with the project that I created. And right here we have the capacity. It just creates a new object of elements right here and of type T that was indicated from the user. And now we're going to look at the grab. So right here, if the bag is not empty, it removes and returns a random element from the bag. Otherwise, it's going to return null. So if the bag size is less than 0, it's going to throw a runtime exception, because what's there to remove if there's nothing in the bag? And then after that, if that does not apply, we're going to find a random element and we're going to apply it to a variable of type T, because we are not specifying which type the user is using. We're going to remove that one element, subtract the number of elements, and return the variable that we have created. And you see this remove method comes in the array collection, so we kind of have this for us. We have find, add, and remove here all done for us. So now count. It returns a count of all the elements E in this collection such that E dot equals target. So what we're going to do is we're going to traverse through this array that we have of right here of the bag, and we have the size method, which was in the array collection, and we are going to traverse through all of them. We're going to see how many times we have the target appearing in our array. We're going to add 1 to the count every time we do so, and then we're going to return the count. So now we have remove all. Removes all elements from this E collection such that E dot equals target, and removes all the number of elements, and returns the number of elements removed. So unlike this one, this count right here, this remove is going to remove them and return the count that it appears of target T. So we're going to traverse through the array, going forwards except this time, because we don't want to have to deal with removing an element and then skipping the next one if we go forward, so we're going to go backwards. So same thing here. If our element equals the target traversing through the array, we're going to use this remove from the array collection. We're going to remove it. We're going to subtract 1 from the number of elements, and we're going to add 1 to this count, and then at the end we're going to return that count. And now clear what this does. If the capacity specified is greater than 0, then we're going to create a new object of integer capacity, else we are going to create a new object of def cap. And I'm pretty sure def cap was specified in here. Yep, it is 100. And so basically what we're looking at is if there's a specified capacity, then we're going to create one of the user's choice, and if not, then we're going to create one of the default one. So now let's look at the link bag implementation. Here, as you can see, we only have one constructor, and we are also going to be extending this linked collection right here, where we have the add, find, size, contains, remove, get, is empty, and is full methods, which is very useful for completing this and will make the process a lot less tedious. So obviously, if the size is less than 1, we're going to be throwing a new runtime exception, because what's there to grab if there's nothing in the linked list? And then else, what we're going to do is we're going to create another random int like we did in the previous grab, and we're going to set a count equal to 0. And since you can't traverse through a linked list, we're going to use a self-referential class of ll node t, and while doing so, we have a new node temp, and it is set to the head, which is in here, which is a new LL node, which is just an item in memory. And while our count is less than the random -1, we are going to get the next link in the linked list. And then at the end, we're going to remove the temp, and we're going to return the temp. So count here, this time we are looking at how many times the count appears, and the count appears of target. So we're going to have a count set to 0. We're going to have a new LL node temp of head like we did right here. So we're starting at the front of the linked list. And while the temp.getLink is not equal to null, so while there's another spot in the array, what we're going to do in the linked list, is what we're going to do is we're going to get the info of the current link in the list, and if it equals the target that was passed through, we're going to add 1 to the count, and if not, then, well, if not, we're always just going to get the next link, and then we're going to return the number of times that target was in the linked list. So now, very similar to the count method, the remove all is also going to return an int, and except we're going to remove it and not just get the count of times target was specified in the linked list. So we're going to have our LL node T from the self-referential class. We're going to set it to the front of the array, which was the head. Sorry, I apologize, linked list. And while the next link is not null, so while there's another link in the linked list, we're going to get the info of the current link, and if it equals target, we're going to add 1 to the count, and then we're going to remove the current temp, which is the current node in the linked list. And then we're going to end up returning the number of times that target was present in the linked list. And now here, this clear method, all this does is it just takes the number of elements, sets it to 0, and after that we're just going to set the head of the linked list, so the start of it, to null, so there is a new linked list beginning. And just to go over these two strings really quickly, we can go over this array first. So what we're going to do, we're going to have string return, we're going to set it to basically nothing. So we're going to loop through the entire array. We're going to add return. To the return string, we're going to add the elements at I. And if I is not equal to the size -1, then what we're going to do is we're going to add a comma. So if I equals size, basically the last one in the array, we're not going to add a comma. And we can test this here. Pretty sure. Yes. So you can see it's not added to the last. Apple, banana, cherry, banana, date. Size is 5. Random item was cherry. As you see, we're not grabbing a specified item. If we use the grab, we're just going to be getting a random item. In this case, it was index 2. And number of banana in the bag is just 1 right now. And the bag contents were apple, banana, and date. So we're going to check out this linked bag toString, and we're going to have a new LL node and obviously a string return, which we're going to return at the end. So while there's another link in the node, what we're going to do is we're going to add the current info to the link, and we're going to have the temp be the next temp in the array. So we're going to get the next link, and this is going to look like this right here. I don't know why this is being all goofy. There we go. Oops. Did not mean to do that. Sorry for the technical difficulties right here. And we are going to run this really quickly. Wherever this is. Here we go. There we go. That's what we want to see. So, as we can see, everything in this is random. So the size is 5. You just grab a random item and then remove it. So basically you can see that there is a principle of randomness in this bag ADT, and it can be quite useful and efficient if you're using it the right way, but there's only minimal amounts of scenarios in which you will be using this. And once again, I would like to just say thank you for watching this video. I hope you enjoyed and learned something, and if you have a question, ask me in the comments or shoot me an email. And thank you for watching. Have a great day.